Hello, this video is part of a series of videos designed to teach you the basics of assembly modeling. Building an assembly without design intent is like building a robot without a game strategy. You might finish, but you probably won't like the result. In this first part, I'll discuss some important principles to keep in mind that will ensure you build robust assemblies of your robot in SOLIDWORKS Design. Let's get started. Here we will quickly highlight two main ideas. First, design intent drives every decision, including first component, orientation, and mate choice. And second, employing basic planning and organizational strategies can greatly improve the performance and editability of your assemblies. We will use a basic two-stage elevator as the basis of this video series. In CAD, design intent can be defined as how a model is to perform or function throughout the design process. As you can see in the Feature Manager design tree, there are four main subassemblies and a list of folders. The first subassembly in the list is the main structure. Based on design intent, this is the best choice for the first component in this assembly because the other components are attached to and move within it. Within the main structure assembly, design intent indicates that the best choice for the first component would be the bottom tube, because all of the other components are fastened to it. Notice that the orientation of all four subassemblies is the same. This orientation choice is also made by considering the design intent of how the subassemblies relate to each other in the top-level assembly. Notice the origins of each are in the middle because, based on design intent, all four of these subassemblies share the same central plane. In the 3D assembly environment, components have the ability to move in 6 degrees of freedom, 3 transitional and 3 rotational. Adding mates constrains components and removes degrees of freedom. When mating components together in an assembly, it can be difficult to choose which mate is the best. Considering design intent can help you decide. Consider these two components which are designed to fit together. The tube plug is slightly smaller than the inside dimensions of the tube and is bolted in place. There are several ways to choose mates that reflect this design intent. Two concentric mates, using the faces of the holes shown here, would accomplish this and fully constrain the components with the tube plug centered in the tube and all holes aligned. Another option could be to use two width mates using the faces shown here. This would center the tube plug within the tube. But then you would need a concentric mate to fully constrain it, ensuring alignment of the holes. One choice that would not work would be to use the faces shown here, the inner face of the tube and the outer face of the tube plug, with a coincident mate. This would offset the tube plug within the tube, due to the tolerance between the two components, misaligning some of the holes. Another thing to consider is the organization of your assemblies. Here you can see several folders. These contain the components that are added at this level of the assembly. One folder for the components relating to the motors, gears and pulleys, shafts, spacers, and one for all the hardware. Organizing your assemblies this way matches design intent and makes it very easy to find things and make edits. In the following parts of this series of videos, we will put together this elevator assembly and see these principles in action. Thanks for watching. If your first robotics team is ready to level up, get free SOLIDWORKS Design software, training, and resources to power your team's success, and equip your team with professional tools used by real engineers.